Alright, welcome back. Let's get the molar mass of AlCl3 here. So we know the molar mass of Al is 27 times 1 equals 27. We know the molar mass of Cl is about 36 times 3. So that is going to be 36 times 3 is 90 plus 108. So 108, 128, 130. I'm so bad at math. 108 plus 27 is the same thing. So this is 8 plus 7. This is 5. 1, 2, 3. 135. 135 grams of AlCl3 for every 1 mole of AlCl3. 135. I'm stupid. Alright, so how many moles of chlorine gas are produced from 100 grams of AlCl3? So that's what we're starting with. 100 grams of AlCl3. Okay, so because I always use this one and I have grams of AlCl3, I'm going to use this one. I do not see grams of Cl2 anywhere, so I do not have to use that one. So there are 135 grams of AlCl3 for every 1 mole of AlCl3. That was done. And there are 2 moles of AlCl3 for every 3 moles of Cl2. That's done. So my answer is going to give me some moles of Cl2. I'm going to take 100, I'm going to divide it by 135, I'm going to multiply by 3, and I'm going to divide it by 2. And that's the answer that you will get there. So use your answer to calculate the pressure. Again, if it was energy, it would be mc delta T. Because it's pressure, it's PV equals nRT. I'm going to rearrange it for pressure. So pressure equals nRT over V. I'm going to list out everything that I do know. I know N from up here, so that's some moles of Cl2. R equals 0.0821. T equals 35 degrees Celsius plus 273. So that's going to be equal to 308 Kelvin. Let's see if I did the math. 273 plus 30 is 303. 303 plus 5, 308. Good job. Volume is going to be 0.5 liters. That was right here. So I'm going to plug it all in. And some moles of Cl2. Now I'm just not doing the calculation because I do not have a calculator on me. But you're going to need to do the calculation. Multiply by the temperature divided by 0.5 liters. So the numerator, you're going to have the moles, N, multiplied by the 0.0821, R, multiplied by T, which is 308 Kelvin, divided by 0.5. You're going to get some number in atmospheres. Not a big deal at all. Alright, question number 4. Let's get the molar mass, percent composition, and gas diffusion speed. Okay, please list these 3 here. So, argon. I'm not sure the molar mass of argon. Grams per mole. It's going to be 100% argon. I'll get back to argon in a second. Ethane is C2H6. So let's list this out. Carbon. We have 2 carbons multiplied by 12, which is going to be equal to 24. For hydrogen, we have 6 times 1, which is going to be equal to 6. So the molar mass of ethane is 30 grams per mole. The percent carbon is going to be equal to 24 divided by 30 times 100. And the percent hydrogen is going to be equal to 6 divided by 30 times 100. This will be percent carbon, and this will be percent hydrogen. This is 30 grams per mole. Remember, these all should add up to around 100%. For carbon dioxide, it's CO2. So you have carbon which is 12, times 1, and you have oxygen, which is 16, times 2, so you have 12, 32, this is 44 grams per mole. So for percent carbon, you take the total carbon, which is 12, divided by 44, multiply that by 100, and you take the total oxygen, which is 32, divide that by 44, and multiply that by 100. And you get your percent carbon, and you get your percent hydrogen, and they should all equal to around 100%. So please list the gas in order of slowest to fastest. That means it should be heaviest to lightest. I'm not sure what the molar mass of argon is, but I know that argon is the heaviest here. Neon, yeah, I believe it is. So slowest to fastest, it's going to be argon, and then carbon dioxide, and then ethane, in that order. Please explain the reasoning behind your list. So light gases move faster than heavy gases at a given temperature. Alright, here we go again. Propane gas. Propane is going to be C3H8. So you have carbon, which is 12, times 3, 36. Hydrogen, which is 1, times 8, which is 8. So C3H8 in this case is going to be 44 grams per mole. Once again, much like carbon dioxide, so 36 plus 8 is 44. For percent carbon, you're going to take 36 divided by 44, multiplied by 100, and that's percent carbon. For percent hydrogen, you're going to take 8 divided by 44, multiply that by 100, and you're going to have percent hydrogen, and those should equal up to around 100%. Neon, I believe the molar mass of neon is around 20 grams per mole, but you could correct me on that one. I believe it has 10 protons and it's about 20 grams per mole. It's going to be 100% neon if it's the only element present. And water vapor, let's not let the vapor throw us off. I just put vapor because we're talking about gases. So each hydrogen's 1 times 2 is equal to 2. Each oxygen is 16 times 1, 16, 18 grams per mole. So percent hydrogen is going to be equal to 2 divided by 18 times 100 percent hydrogen. For the percent oxygen, it's going to be 16 divided by 18 times 100 equals percent oxygen. Okay, fastest to slowest. So they want, in this case, lightest to heaviest. So our lightest gas in this case is going to be water. So H2O. Next in line is going to be neon. And the next in line is going to be methane. Because this was 18, this was 20, and this was 44. Question number 5. Talking about phase diagrams here. When liquid water is placed in a constant temperature vacuum chamber for a few minutes, the water will boil and become a gas. What is this process called? Well, you're going from liquid to gas. So liquid to gas, that is called vaporization. You can also call it boiling or evaporation. Draw a phase diagram in the box below and use an arrow to indicate the process. So this is pressure, this is temperature, this is solid, liquid, gas. This is called the triple point. It's the point for which all three phases are at equilibrium with one another. They said it was a constant temperature chamber, and for a few minutes the water will boil and become a gas. Constant temperature chamber, so temperatures remaining constant.